All right, y'all ready to get started? All right, the clicker works. Everything's going great. So my name is Evan Johnson. I lead product security at Cloudflare. Cloudflare, I'll get into Cloudflare, but I'm an engineer at heart. A little bit about myself. I'm an engineer at heart. I have worked at a bunch of startups. I worked at LastPass, who's one of the sponsors at this event. Hats off to all the sponsors. And diet soda enthusiast. And at Cloudflare, the product security team is a security team at a security company. The entire security team is, not just ours. But I feel like that's a little different distinction. A lot of the vendors here are security companies. A lot of the people here might work at security companies, and I think it's different because when you're at a security company and you're worried about security, everybody looks to you for answers, and you're in the middle of a lot of decision making at the company because if the company really cares about security, then you're really somebody that they want to talk to and learn from. So Cloudflare, the business is a giant reverse proxy. We have a ton of products from Zero Trust to CDN to image resizing to Cloudflare Workers. You can run your code on our servers. The scale at which we operate is pretty large. We're doing like 36. These are old stats, and I think we're getting new stats soon. 36 million HTTP requests a second, 19.8 million DNS requests per second, and then we block 124 billion cyber attacks a day, which I think means like WAF events, bots, all sorts of things. But we have over 200 points of presence around the globe, and so needless to say, our security is really important with all of that hardware and all of those requests, and those are other people's requests, other customers, their website, all of their whole website will flow through our servers. So all of that data is super, super sensitive. Okay, but this talk is two things. One, it is a story about how we transitioned from an old school traditional perimeter security model to Zero Trust, FIDO, a lot of those things. It's a war story of sorts, and it's also the last thing standing between you all and dinner or you all and a drink. So feel free to speak up, raise your hand if you have, make it interactive if you'd like, throw a shmoo ball at me. But it's meant to be informational and fun, not a sales pitch. Okay, so traditional security model. Where did we start? I joined the company in 2015. I joined Cloudflare in 2015, and there were about 100 people at the time. Small, engineering-focused company. And they had a traditional security model. So when I'm an engineer, scrappy startup, you get woken up in the middle of the night. Your phone starts paging you. You're like, what is this for the 10th time this week? What is it this time? And you go to see your metrics or see what's alerting you. And you'd have to log into the VPN on your device. You're waiting for your second factor TOTP code. And people hated it. It was a miserable experience. We didn't allow the VPN on anybody's phone. So they actually weren't using their phone for this. People slept with their laptop either under their pillow or tucked under their bed. And it was just miserable for everybody. Everybody universally hated it. And so, but also like me as a security practitioner, I looked at it and I was like, this is a lot of heartache for not a lot of benefit. We have one single box that we're funneling all of our traffic from all around the globe through, one single choke point. And so the people in London and Singapore and all over the world, their connection is so slow because they have to take all their traffic for all of our internal sites and run it through this one little box. It was one of the, it was really tough to control who had access to what with this model because things were just IP allow listing the VPN box and not actually, we weren't actually integrating with like, put this in this VPN profile, and we had none of those capabilities. And so that traditional perimeter security model, the moat and castle, was more like it was made by Fisher-Price. It was not a very good moat. It'd be great if it was a good moat, but it just wasn't a good moat. So at this time, we wanted better. We knew that we could do better. And me in 2018, what I really wanted was zero trust, whatever that means, because it's such a buzzword. And I'll get to that later. And WebAuthn. I wanted something that was unfishable, because if we were going to go through all this trouble redoing a lot of our identity and access management infrastructure, I wanted it to be future-proof and resilient. And what else? I wanted the ability to do role-based access control, really good custom and automated approval processes. I wanted to basically do whatever I wanted to do, which who knew what I wanted to do when I saw what applications we were going to be building in the future. I wanted it to be custom. So that's where we found ourselves. But before that, there was an interesting project internally in the company. This is open source on GitHub. And this was an original version of the Cloudflare Access product, Nginx Google OAuth. And all it did was it turned our edge servers into a little identity-aware proxy. It's about, I don't know, 60, 70 lines of Lua that we ran in Nginx. It wasn't pretty, and it did the trick. And it was perfect. So overnight, this thing changed the game. So those SREs and operators who were sleeping with a laptop under their pillow, suddenly we put our metrics, Grafana, behind this. And now they could log in, they could have their Grafana dashboard bookmarked, and they could log in with Google OAuth without having to get on their laptop, connect to the VPN. They would just get paged, look at their phone, pull up their Grafana dashboard, boom, and instantly know what the problem was, instantly know if it was going to resolve itself or what. And so we had built this in 2015, and prior to us deciding we wanted to go big in identity and access management, redo a lot of things, this was just kind of out there and something that we were thinking of productizing. And it was at that time in 2018 where we decided this had been completely rebuilt, completely redone, and more productionized. And we said, let's go big with this little Cloudflare Access project we have. It was a small product, just about 3 or 4 people working on it internally, and we weren't really sure where it would go. And we decided to onboard all of our internal applications to it because we knew that we had to do something to start changing what we had. So in 2018, we made the big decision to move everything behind this kind of smaller product we had, and then we started cutting some employees' VPN access. So if you were in recruiting or HR or a lot of these teams that definitely didn't need it, they could do their whole job with this identity-aware proxy, then you did your whole job with the identity-aware proxy. We removed you from the VPN. And some of that was out of necessity because we ran out of licenses. And so if you got to work early, I was an early riser, and I would get into the office early around 7 or 8 a.m. By 11 o'clock, we were out of licenses, and I would get kicked off the VPN by the most recent person. So yeah, we started booting those people off the VPN. That was step one. This is kind of how that Nginx OAuth thing works that I linked on GitHub. So it's kind of complicated, but it's not too bad when you go step by step. When you load up app.site in this example, you hit our edge server. It does a OIDC or OAuth redirect with an identity provider or SAML with an identity provider. We figure out who you are. We have some basic grouping and rules engines, and then we give you a JWT as a cookie, and then forward your HTTP request on to the origin server. The origin server in data center there on the right-hand side of the screen validates that JWT that you then send along with every HTTP request that you make. And that works pretty well. There are a few funky things, but it's worth noting that it's very specific. Identity-aware proxies are very much an HTTP thing. And it's easy to bolt things on to the cookie field or to HTTP headers, but it's pretty specific to the HTTP protocol. Okay, so we had great success with that. That was circa 2018, for a couple months in 2018. Around the same time, we started ordering YubiKeys for all of our employees. So there's two kind of interesting stories from this. One that I don't have slides for, one that I do. We've ordered several versions of YubiKeys at Cloudflare. The first was the old Titan keys for NFC. Actually, before that, it was like the Bluetooth ones. I forget what those were called, but they were made by a third party, I think, from Google. But it worked on iOS. That was the first version that I knew of that worked on iOS. So we bought one of those for everybody, and then we bought one of the Nanos that's in everybody's laptop. I've got one right here in my laptop. And that was the first version of it. But we ran into problems pretty quickly. We distributed that hardware at a whole company retreat. We were small enough, and this was pre-pandemic enough, that we got the whole company in one place in Napa for a weekend. And when everybody was there, we gave them an envelope of 2 YubiKeys that were already registered with an identity provider. And that was great until everybody flew home and people started losing them. And we said, oh my God, how are we going to get a YubiKey to this person in Singapore tomorrow if and they're locked out of their account? We've got to figure all this stuff out around how we support these people when they lose their keys. And then what happened a few months after that? In March or April or May, one of those 3 months, there was an issue with those Google Titan keys. And instantly they were revoked across, I don't remember the specifics offhand, but Google decided that the Titan keys had a bug in them. There's a vulnerability in the Bluetooth Titan keys. And they said, just throw them in the trash, and we will send you new ones. So there was a big recall with those. And then we had, for months, no Titan keys. And we've gone through many, many iterations of these. And today, we have fully FIPS-validated YubiKeys for NFC and the Nanos. And we've done a few iterations of these rollouts. But it was not an easy process the first time. We thought it was going to be really easy. We did all this work to pre-register them. And then it ended up being a little more complicated than that. And today, I think we're an enterprise customer of theirs, where Yubico, where they handle all the logistics for us, which is very nice because that's not what I want to spend my time doing. Second, enforcement. So one thing that we grappled with was when migrating from TOTP, everybody was using Google Authenticator or Authy or whatever TOTP app they were using. We wanted to start enforcing that they use their keys somewhere. But at the time, we couldn't do that with our identity provider. We didn't really know how to enforce it and how to actually make the switch from using one to the other without it being a really drastic experience for people where they're locked out. Like we needed a method for selective enforcement. And we ended up being able to find one. And this is what it looks like. So when you're logging into our identity provider, we get this OAuth thing back. And in the AMR, please, this is the one place I can actually ask this question. In the AMR authentication method OAuth handshake, there are all of these different annotations about how you logged in. And what we found was if you used a YubiKey, it said SWK, which is software key according to the spec. And I haven't been able to figure out if, I don't know why they chose SWK or software key. They have an issue in their OAuth flow or what. But all I know is if we required that it said SWK in the blob returned in the OAuth handshake, then that meant they logged in with the YubiKey using WebAuthn. And if anybody knows why that is, it doesn't feel right to me that it's a software key. But if anybody knows why that is, this is probably the one place I can ask and hopefully get an answer from somebody who knows better than I. But yeah, we figured out that SWK meant YubiKey, and we started enforcing, we built into the Cloudflare Access identity-aware proxy that you needed to see the SWK on our to access some of our internal sites. So we built a feature that supported enforcing certain AMRs in the OAuth response. And then this is what it looked like in Terraform. This is a real Terraformed internal Cloudflare app that requires a specific identity provider, requires that little SWK thing to say that you have to do your YubiKey to log into there, and requires that you're in that group everyone, which excludes contractors, and we have some rules around that, but this is the Terraform to do that, to do actual selective enforcement. And selective enforcement ended up being a huge deal for us. That was one of the biggest forcing functions and things that made this project successful. Because for a long time, this is what we were doing, where these were the metrics around use of TOTP versus use of YubiKeys at Cloudflare. And actually, it's not quite TOTP. It's just other. So it's who is using WebAuthn and who is using something else. So if you got locked out and you did a recovery with an IT administrator right behind you, that would still count as soft token, but it wouldn't count as WebAuthn. So this is slightly mislabeled, but it's pretty good. But yes, around this time, we had given everybody these security keys in 2018, and we hadn't seen the adoption really take off because we hadn't been able to enforce it. And then around July 8th, it was around mid-July, July 20th of 2020. Does anybody remember what happened? What was that? No, that was, I think, early. Pipeline is a good guess, but it was not the pipeline. That was a big forcing function for us. Everybody forgets this day. It was mayhem. On Twitter, Twitter got hacked, and Elon Musk is tweeting Bitcoin scams, and Joe Biden was tweeting Bitcoin scams. It was crazy. That day was mayhem. And we were like, we don't want that to happen to us. And so that day, we had just built the feature probably 2 weeks prior, and that day we were like, let's turn it on for a bunch of internal, for like the top 3 most sensitive internal apps. And overnight, it changed the entire trajectory of WebAuthn, just enforcing it on 3 sites, because it instantly gave employees a training ground to go where they had to use their token. So there's always these holdouts who are not going to use the new tech until they absolutely have to. There's a ton of people who are like, this is great, this is more secure, I'm going to use it. There's a ton of people who maybe just needed coaching one time, and then they figured it out, and then they wanted to use the WebAuthn tokens. And then there's a ton of people who are like, I'm not going to figure that out until I absolutely have to. And then as soon as they had a place where they had to learn it, it completely changed the trajectory. So this is the metrics around how quickly there was an uptick. And then later that early 2021, similar to the recent bout of social engineering attacks that you've seen published in the news, we started getting antsy about some social engineering attempts for that we had seen targeting us, and we made the flip to enforce security keys everywhere. That day, people started targeting our employees, and so we enforced it across our entire organization. We said that has been soaking for long enough. People have had plenty of time to figure out how to use these tokens, and overnight it went down to just about 0, and it's not quite 0 for that reason that I explained earlier. People who get locked out, there's a few administrative functions that technically aren't logging in with the WebAuthn. But yeah, these are my favorite graphs that I've been a part of at my time at Cloudflare. So this is what a similar social engineering attack looked like in 2022. This was just a few months ago. This is the one that Twilio was unfortunately a victim of. And this is what it looked like on the left. I got 3 of these text messages in 3 minutes targeting myself. And I was actually at a happy hour with some of the other people who rolled out WebAuthn with me at Cloudflare. And we just kind of cheersed and we were like, haha, we don't have to do anything for this. We didn't do nothing, but we weren't that worried. That was a really fortunate position to be in. Okay, so that's about the enforcement of WebAuthn and how we kind of dialed that up over time. But what about non-HTTP protocols? That works great, but Cloudflare is a network where we have DNS, which, I mean, there's not authentication there, but everybody in the world uses SSH, which now supports the -SK type keys. You can do your ED25519-SK when doing a SSH keygen. But there's other protocols too. It's not, the whole world isn't HTTP and SSH. A lot of it is, but we needed something that was a little more, had the ability to be customized. And I'm going to skip this because we're running low on time. But in the end, this is kind of how we handled that. And this is the, maybe I should go one step further. I'll come back to that right after this. So we built this Cloudflare D thing, which is, it establishes a secure tunnel with our edge. It runs on both the client side and server side. It's an open source project. All you need to know is it makes a connection to Cloudflare and holds it open. Leveraging that, we built this super complicated handshake where over HTTP, you still do the same old OAuth, OIDC, log in with your identity provider, create a JWT token, authenticate who you are. But then we bolted on SSH certificates onto that protocol, similar to, I think years ago, Netflix released their Bless for SSH certificates. They have a open source product called Bless, if you're not familiar. And basically, we will mint and sign SSH certificates for people who want to SSH in. And then if you run that Cloudflare D thing I just showed you on both the server side and the client side, we can send your whole SSH connection over HTTP, which works great, actually. Who would have guessed? And securely authenticate you into wherever you're trying to SSH to. And that works with UDP-based protocols, TCP-based protocols, anything. We just turn them into HTTP, and it worked great. So now we can send anything over this identity-aware proxy, and it works just fine. Sometimes people complain that it's a little slow, but I tell those people to deal with it. We also built this thing called Grouper. Actually, we didn't build this, but we heavily customized it. It's I think it's a Dropbox project called Meru, and we use this to replace how people requested access to things. So let's say you're an engineer and you're getting paged in the middle of the night for some issue in some product that you're required to support. Our engineers don't have SSH access to our machines around the globe. Our operators do, but our engineers do not. And so if they really need SSH access at that moment, they can go in and click join, and this will, they can get approved, and then with this approval flow, there's a certain set of approvers for the people who are responsible for saying who can and who can't access SSH into our nodes, and then they can SSH in over this wild back and forth. And it works just like, as long as they have this special SSH config in their SSH config, which Cloudflare D auto-generates because it's not too difficult to auto-generate, then it just works fine. So an engineer can go from not having access to authenticating into production with a YubiKey, having never created a SSH key before, in about 5 minutes, which is fantastic. Then we're getting into some weird futuristic stuff. So this is probably not that futuristic anymore, but we have this Warp VPN that we offer, and we're starting to authenticate people based on the private key that they have. Well, not the private key, but the public key used in the WireGuard connection. So Warp is a VPN that does a WireGuard connection from your devices to our edge, and that's a lightweight kind of open VPN-like protocol, but it's way better. And when you first download the Warp app on either your desktop computer or your phone, you generate a public-private key pair, and then we memorize what your public key is. We can associate it with your identity, and then we have an additional layer of knowing who you are. So it's kind of a way to do that device binding. And this is a terrible diagram, but at its core, that's what it's doing. We're baking this private key into your keychain. You're authenticating and using your public key in the key agreement for WireGuard, and then we know who you are, in addition to what you log in with into our identity provider. And this is super experimental. So this is an SSH connection that somebody just went to this URL, and it's SSH in the browser. Have you ever gone to Google Cloud and you press like SSH into the VM and it just loads this SSH window, and you're like, wow, how do they do that? Some front-end engineer must have spent a ton of time on that. We have a very similar product, and I'll tell you how we did it. We compiled it to WebAssembly, the SSH client, and so it just runs in the browser and works really, really well. So this is pretty, we don't use this a whole lot internally, but it's really cool, and we're looking for opportunities to use it internally as part of our security model. But I do think it has some neat properties, and it's super lightweight, so I think it's cool. And last but not least, in part of our zero trust architecture, we do this remote browser thing where we have a browser running in the cloud that will sandbox suspicious stuff that you open on your. We acquired a company that does this browser, and that does a remote browser, and it actually works really well. It's Chrome running on our server, and then we rasterize it, I think is the right word, into a PNG, send it over a WebSocket, and you just are looking at a PNG of the web page rather than the actual web page. So it works really well, and we've incorporated this into our zero trust kind of architecture, where when you're clicking on suspicious links and going places you maybe shouldn't, we will automatically, we have a resolver, a DNS resolver, that will send you to the remote browser version of that, which is neat, but kind of experimental. And we're almost out of time, so the most important thing, takeaways. So I've got these weird kind of things in there that aren't usually typically zero trust architecture, that aren't typically WebAuthn and FIDO. Another one that is worth mentioning is like email security. Cloudflare in our we have a zero trust roadmap.org, and we prominently put email security on that list, partially because we bought a company that does email security, partially because this reason, where you got to take the small wins where you can, because this was a multi-year effort, and switching on FIDO2 and WebAuthn, switching on a lot of these things take forever, and being able to incorporate small wins into things that you say are zero trust can, I think, help build support for it internally if you're tasked with doing this. So whether it's zero trust or not, I would use the ambiguity of what zero trust is to your advantage as somebody rolling it out, where you're like, yeah, this win that we had, that was totally zero trust. Like, let's go. So take the small wins where you can, for sure. Second, selective app enforcement. If you can't do it and you're trying to roll out WebAuthn and YubiKeys or whatever passwordless thing you have, you need it on one site where it's required as a training ground. And that will completely change people's behavior, which I have metrics to prove. Last, actually not last, top-down support at Cloudflare. We had plenty of top-down support from our CEO to CTO. Everybody wanted this. The hard part was when we started, the technology wasn't quite there. Like iOS didn't release support for this in the Safari browser until we were long down our path for this. And then there's still issues. Like on Mac OS X, the support for SK security keys isn't compiled into the SSH keygen binary that they ship. And so there's all these little things. We found that we had to do specific, on some of our SAML sites, we found that some of them just wouldn't work if it was app-initiated SAML flow versus IDP-initiated SAML flow. And like there's all these details that you'll run into that are problems. And you need the top-down support to be able to like push you through a lot of those problems because you're going to hit issues and people are going to not like learning new things. So get top-down support with those easy wins that may or may not be zero trust. And then last, you've got to think about your non-HTTP based protocols. So it's great if I could say, okay, everybody in HR, everybody in recruiting, everybody in whatever, those people are fully zero trustified. Those people, their whole jobs can be encompassed in the remote browser. The recruiting team, if they're going to open up these shady PDFs from candidates who are trying to hack the recruiters, let them open them up in the remote browser. That's great. But as soon as our engineers start doing something at the network level, you still want those protections. And so you've got to think that through. But yeah, that was my talk. We're a little over time. Is there any questions? I'm more than happy to answer any. Thanks for coming, everybody.